Okay, so we were looking at Bianca's savings. And when we're looking at the table, the choice that we're going to do for working our way backwards is using this point 8, 26 and 12, 38. So to go from 8 to 12, we're going up by 4. And to go from 26 to 38, we're going up by 12. Now, the reason I chose this point is because I need to work my way backwards to find that y-intercept, which is when x is 0. So if I'm at 8 and I'm going backwards by 4, I will make my way to 0, right? If I go work backwards, 8 minus 4 is 4. And then work backwards with this 26. 26 minus 12 is 14. Great. Now I'm going to do it again to get to 0. 4 minus 4 is 0. And 14 minus 12 is 2. So essentially what we have here is our table 0, 2, 4, 14, 8, 26, 12, 38, right? And now each time our x's, our input is going up by 4 and our output is going up by 12. So what that tells us is that our initial value, now we know, is $2. So she started with $2 in her account, and the slope or the rate of change was $12 for every 4 days, which 12 divided by 4 is 3. So it's $3 per day. Now, if we used an equation, which would be y equals our slope is 3x plus our y-intercept, which is 2. We could plug in again 30 for x. So we'd get 3 times 30 plus 2. 3 times 30 is 90. So close. Plus 2 gets us 92. So the slope was the same. We were going up by $3 a day. The only thing that was different was starting at 2 versus starting at $3. And that makes the difference of $1 at the end of the month. So at the end of the month, Adam will have the most money, and that will be $93. Beautiful. When you feel all set and you have everything here, feel free to go to the next slide. Beautiful. So we have Fred and Jean in their hang gliding. Fred is 600 feet above the ground and is descending at 10 feet per second. So here's Fred's equation. We have our descending slope, which is our rate of change, which is -10. It's negative because he's descending, going down. And we have our initial value, which is at 600 feet. And the rate of change would be, this is feet per second. So feet per second, if we wanted to write our unit. And Jean, their rate of change, every 1 second, see how these seconds go up by 1, 0, 1, 2, 3. Our height is going down by 15. So that's going down faster. So that's going to be a faster rate down to the ground. And our starting value, when x is 0, we have that initial value of 480 feet. So Jean started lower, but is going down faster. Beautiful. So there's our rates of change and initial value. Push ahead to slide 7 when you're ready. A whale comes to the surface of the water, cool, at 80 feet per minute from a depth of 1,000. So now our y-intercept is negative because it's below sea level. That initial value is -1,000 feet. and it's coming up. Our rate is positive because it's increasing, getting closer to 0 or closer to sea level at 80 feet per minute. Great. Looking at function B, we have another whale in this table. So of course we see our minutes going up by 1 again, 0, 1, 2, 3. And our depth is increasing by 100. It's going from negative 100 to negative 700 to negative 600. So we're going up 100 per 1 minute. So 100 feet per minute for our rate of change, which is faster than function A. And our depth is when x is 0, we see our depth at negative 800 feet. So we're closer to sea level, we have a higher initial value, and our rate of change is higher and faster, more steep for function B. Beautiful. Last one here, slide 8. It says determine which function has a greater rate of change and y-intercept. So for function A, we love this because here's our rate of change, 3/4. Nice and easy. We just pull it from our function, and here's our initial value at 2. Our initial value for function B, when x is 0, y is negative 2. So far we know our initial value for function A is greater because 2 is bigger than negative 2. And when we're looking at our rate of change, we look at how x increases. It's going up by 1 each time, negative 2, negative 1, 0, 1, 2, 3, as our y's are going up by 4. So we have a slope of 4 over 1, or 4, which is, of course, greater than 3/4. So function B has a higher rate of change, greater rate of change, but function A has a greater y-intercept. So hopefully you feel a bit more comfortable being able to compare our intercept and our rate of change in different functions using equations, graphs, and tables. On the last slide, this is just a little weather report. I want you to think about how you are feeling internally. If you were to give yourself an internal weather report, it can be about this class, it can be about your personal life, it can be about how you're feeling in this moment. Whatever you feel like you want to share, just let me know. Just do a little self-reflection on how you're feeling. And also, if you do want to find a time to meet with me, you can leave me a message on this slide as well, and I'll send you an email to find that time. Okay. Take care, my friends. Enjoy the rest of your day, and I'll see you in the next video. Bye.